Welcome to the ultimate math game. Solving an equation isn't about memorizing scary rules. It's about acting like a judge keeping a balance scale perfectly level. A linear equation is just a math puzzle with a single mystery number, usually called x. This x is regular and predictable, no wild exponents like powers of 2 or 3 here. Our main mission is always the same: get that mystery letter x completely by itself on one side of the equal sign. Let's tackle our first real puzzle. Solve 4 minus 3x equals 2. Look closely at that 3x. See that minus sign sitting right in front of it? Negative terms are troublemakers. It's always much easier to work with happy, positive numbers. So, our first strategy is to transform that negative 3x into a positive one. To completely cancel out a minus 3x, we do the exact opposite, we add 3x. But remember our golden copycat rule. Watch the left side, minus 3x and plus 3x are exact opposites. They completely cancel each other out to 0. They vanish entirely, leaving the number 4 all alone on the left. Our equation is now cleaner, 4 equals 2 plus 3x. Now look at the right side where our x family lives. It's not alone yet. It has an uninvited guest, this positive 2. To banish a positive 2, we execute the opposite operation again, we subtract 2 from both sides of the scale. Let's do the arithmetic. On the left side, 4 minus 2 quickly crunches down to a neat, simple 2. On the right side, 2 minus 2 turns into 0, leaving our 3x isolated. Our equation now reads, 2 equals 3x. But remember, 3x means 3 times x. The ultimate enemy of multiplication is division. To break this final bond and set x completely free, we divide both sides by 3. The 3's cancel out on the right, leaving x isolated. Our mystery number is officially found. X equals 2/3. What happens when our mystery number is scattered all over the place? Let's check out example 2, solve 2x minus 7 equals 5 minus 3x. They are having a total disagreement. It's always easiest to target and move the smaller or negative variable term first. That's our minus 3x. To wipe out that negative 3x, we perform the opposite action, we add 3x to both sides of our balance scale. Time to group our family. On the left side, 2x's plus 3 more x's combine to give us a grand total of 5x. On the right side, the minus 3x and plus 3x cancel out to 0 and vanish completely. Our line is now much simpler, 5x minus 7 equals 5. With our variables united on the left, we need to clear out any plain numbers sitting next to them. This minus 7 has to go. The mathematical opposite of subtracting 7 is adding 7. Let's introduce a plus 7 addition to both sides of our level scale. On the left, minus 7 and plus 7 cancel out to 0. On the right, 5 plus 7 adds up to exactly 12. Our line reads, 5x equals 12. To break the final multiplication bond holding the 5 and the x together, we divide both sides by 5. The 5's on the left side cross out, leaving our variable x completely isolated at last. On the right side, we get 12 divided by 5. This is an improper fraction because the top number is heavier than the bottom. 5 goes into 12 exactly 2 times, with a remainder of 2 left over. So, our final answer is 2 2/5. Before heading into advanced territory, let's lock down our 3 golden rules of algebra into your mental toolbox. Rule 1, the copycat rule. Whatever math operation you apply to one side of the equal sign, you must apply to the other. Rule 2, the undo rule. Always use the mathematical opposite operation to detach or move a number across the line. Rule 3, the reunion rule. If your variables are scattered on both sides, gather them together first using addition or subtraction. Welcome to stage 2, equations with brackets. Think of brackets as locked gift boxes holding secret numbers inside. Before we can organize our variables, we have to unlock the box using the distributive knock. The number outside must multiply by everything inside. Let's put this technique to work on a real monster equation. Solve x minus 2 times x minus 1 equals 1 minus 4 times x plus 1. Let's expand the left box first. we multiply everything inside by minus 2. Minus 2 times x gives us a clean minus 2x. Now watch out. Minus 2 times minus 1 turns into a positive 2. Remember, a minus times a minus always makes a plus. Now let's crack open the right-hand box. We distribute the minus 4 through the doors. Minus 4 times x is minus 4x. Next, minus 4 times positive 1 yields a negative 4. Let's write out the complete, flat equation with all boxes successfully open. Don't jump across the equals sign yet. Let's tidy up each side locally first. On the left, regular x minus 2x groups down to minus x. On the right side, plain numbers 1 and minus 4 combine cleanly to leave us with a constant of minus 3. Look at that! Our equation is now significantly shorter and much friendlier. Minus x plus 2 equals minus 3 minus 4x. Time for a family reunion. Let's move the negative 4x across the line by performing the opposite operation and adding 4x to both sides. On the left, minus x plus 4x groups down into a solid positive 3x. On the right, the variables wipe out completely. Now let's evict the positive 2 away from our variables by subtracting 2 from both sides of the balance setup. This yields 3x equals minus 5. To sever that final multiplication link, we draw our fraction lanes and divide both sides by 3. The coefficients cancel out cleanly on the left side, leaving our mystery number isolated. X equals negative 5/3. Welcome to stage 3, equations involving fractions. Fractions can look terrifying, but we have a secret weapon to vaporize them instantly. Look at this new problem. Solve 5 divided by x equals 2. Our mystery variable x is trapped deep inside the dungeon at the bottom of the fraction. Right now, the left side is a fraction saying 5 divided by x. To destroy this division cage, we deploy our inverse weapon and multiply both sides by x. Watch the left side. The divided x and the multiplied x are exact opposites. They collide, cancel out, and completely vaporize the fraction line. With the fraction destroyed, our equation snaps down into a clean, simple flat line. 5 equals 2x. We just need to break the bond between the 2 and the x. The inverse of multiplying by 2 is dividing by 2 on both sides. The coefficients cancel out cleanly on the right, leaving our mystery number x completely isolated at long last. This leaves us with 5 divided by 2 equals x. Since this fraction is top-heavy, let's polish it up and convert it into a neat mixed number. 2 fits into 5 exactly 2 times with a remainder of 1. Our final answer is 2.5, or 2.5. Fantastic job! Now let's unlock the ultimate application of algebra, geometric word problems. This is where we use our equation-solving skills to crack mysteries involving real shapes and measurements. Don't panic, we have a foolproof 3-step master plan to solve any shape puzzle effortlessly. Let's look at the blueprint. Let's crack question 17. The area of the rectangle exceeds the area of the square by 2 centimeters squared. Find x. Look at our given models. We have a rectangle with side dimensions x plus 2 and x minus 1, and a square with side lengths of regular x. Step 1. Find the area formulas. Rectangle area is length times width x plus 2 times x minus 1. Square area is side times side x squared. Step 2. Build the equation scale. Since the rectangle is bigger by 2, we subtract them to form our line x plus 2 times x minus 1 minus x squared equals 2. Step 3. Solve. Let's expand our brackets using multiplication. X plus 2 times x minus 1 transforms into x squared minus x plus 2x minus 2. Now look at this amazing shortcut. We have a positive x squared and a negative minus x squared. They completely cancel out to 0 and vanish. Tidying up leaves us with x minus 2 is equal to 2. Add 2 to both sides, and we find our final value x equals 4. Let's step up to question 18. The area of the square exceeds the area of the rectangle by 13 meters squared. Find y. Step 1. Square area is y squared. Rectangle area is y plus 1 times y minus 3. Step 2. Big square minus small rectangle equals 13. Professor's warning. That minus sign sitting outside means the rectangle area is inside a protective bracket shell. When we expand inside to get y squared minus 2y minus 3, that negative sign outside acts like a total sign flipper for everything inside. Our y squared terms cancel out completely. This leaves us with 2y plus 3 equals 13. Subtract 3 to get 2y equals 10, divide by 2, and y equals 5. Let's crack our final mystery, question 19. The area of the square is exactly half the area of the rectangle. Find x. Our square area is x squared. Setting it equal to half the rectangle area yields line x squared equals 1/2 times 2 times x plus 4 times x minus 2. Look at that shortcut. The fraction 1/2 on the outside and the multiplier 2 on the inside cancel each other out completely. Expanding the right side yields x squared equals x squared minus 2x plus 4x minus 8, which simplifies down to x squared equals x squared plus 2x minus 8. Subtract x squared from both sides to clear the squares, leaving 0 equals 2x minus 8. Move the 8 to get 8 equals 2x, divide by 2, and x equals 4. See? Algebra isn't about memorizing complex paths, it's just about mastering simple balances. For more intuitive, visual breakdowns that make complex topics click instantly, join our community at My Brainy Cafe. Hit subscribe and power up your brain today.